Okay, today we're looking at 12.2, surface area of prisms and cylinders. And just a couple things, again, as always, if you have questions, email me. And you can see now, as we're winding down towards the end of the year, we're only going to do 2 lessons per week. So, but still kind of keep yourself on a regimen of doing a certain amount each day. And again, I can't stress enough, a couple things. Make sure you're showing work to get credit, and make sure if you have questions, please get in touch with me. A lot of times I'll email back a solution or some notes, or sometimes I'll go on your OneNote on the actual worksheet and maybe put a few notes on the problem that you have a question with. Okay. All right, so we should be, again, it's Wednesday, May 20th, getting towards the end. And again, I appreciate all the hard work most of you guys are doing. Just keep it up. We got about another month to go. All right, so we're looking at the surface area of prisms and cylinders, and that's what we are going to find today. Okay, and again, if you're looking at a rectangular prism, you're looking at something like this. So the surface area would tell you maybe how much wrapping paper you would need to put over something like this, a box like this, rectangular prism. Okay. I'm going to move down here. And any one of our prisms, basically they're polyhedrons, meaning they're bounded. They're all bounded by polygons here. Polygon on this side, polygon on this side, and what we're mainly going to focus on is the right rectangular prism and also cylinders, surface area of cylinders. Okay, so that's basically what we're going to do today. And I have one problem with throwing a triangular prism, but I don't know if we're going to do a ton of stuff with that on the worksheets. Okay. There's your rectangular prism. That's basically just like what I showed you here with this box. And there you have the triangular prism. Okay. And there is our formula that we're going to use today. We're talking about rectangular prisms. Okay. And when we're looking at this, our surface area is just going to be 2 times the B. Big B is the area of the base. Okay? So 2 times the area of the base plus P, that's your perimeter. Perimeter of the base. And then you're going to multiply that perimeter times a small h, which is the height. It's going to be your height. Okay? Okay. And again, when you're looking at this box, the area of the base would be this, the bottom here. Okay? Or you could even call the top. They're going to be the same. It's going to be the length times the width. Your perimeter of the base, remember, perimeter is going to be the distance around the base. And that's going to be just adding the length, the width, length and width, or 2 times the length plus 2 times the width, which is distance around. That's going to give you your P, your perimeter, and then this would give you your height. So this is your area base down here. Your perimeter is the distance around the base, and then your height would be right here on your rectangular cylinder. Okay, let's look at a couple of examples. If you wanted to find the surface area of each prism here, I'm going to move this up to the top here just to kind of give us a little bit of room down at the bottom. Okay. Remember, our formula is 2 times, our formula for surface area, SA surface area, equals 2 times the big B, the area of the base, you have that right there, plus the perimeter times your height. Okay? So first we have to find, I like kind of going off here a little bit, we've got to find our area of the base. big B equals our area of the base. And our area of the base is just going to be, that's the area on the bottom here, 6 times 10. Where you have your length times your width. So area of the base is going to be length times width, or 10 times 6, okay, equals 60. So our big B, our area of the base, is going to be 60, okay? Now the next thing we have to find is our perimeter of the base. That's our P in the formula. Our perimeter of the base. And that's just going to be all these sides added together. Well, we know if this is 10, this is going to be 10. If this is 6, this is 6. Perimeter is usually 2 times the length plus 2 times the width. So if we did that, 2 times the length is going to give you 2 times 10, 20, plus 2 times the width, 2 times 6 would be 12. Or we just added them all together, and it's going to give us 32. So if we went with 2 times the length plus 2 times the width, our perimeter is going to be 32 inches. And this should have been inches squared. Area is always going to be inches squared. And our surface area is going to be units squared. Of course, this time it's inches. Okay. Our height, our h, which is our height, is just going to be the 5. Okay. Okay, so our h is going to be 5. So now we have everything we need to work with here. Okay, we've got our big B, our P, and our h, and that's everything within this formula. Just excuse me for a second. I'm going to see if I can get myself a better marker. That doesn't look too good. Okay, that's a little better. Okay, so we're going to do 2 times surface area is going to equal 2 times the area of the base, and we said that's 60. You have all our information. It's just a matter of copying them down. And again, I always like writing the formula right above it. Kind of gives you a track to go on here. Plus perimeter, which in this case the perimeter is going to be 32 times your height, which is going to be 5. Okay? And we put all that together, all right? You've got your 2 times the 60, 120, plus 32 times 5. I always say 30 times 5. 3 times 5 is 150, plus 2 times 5, 10, 160. And we're going to get a surface area of 280 inches square inches. Remember, surface area, anything with area is always going to be in whatever the units are squared. Okay? So that's how we were able to find the area of a right rectangular prism. Okay? Okay, let's look at a triangular prism. I might put one of them on the worksheet or a couple on the worksheet. I'm not going to focus too much on this, but it's something you want to be exposed to. Okay? When we look at a rectangular prism, we're going to do the same thing. Okay? We're going to have the surface area as 2 times the area of the base plus perimeter times the height. Let's look over here again. Always keep yourself organized. So our big B, our base we need our perimeter of the base, and we need our height. Okay? We get our height, which luckily the height's given to you right here. Now, you're almost looking at this as it's a triangular prism, but figure it as being down, like, you know, down the ground. And this is going to be your base. This is going to be where we're going to find the area. Okay? To find the base, or the area of the base of a triangle, remember that's 1/2 the base here. Not the area of the base, but this would be like a small b. Okay? This would be 1/2 base times the height. Okay? And so you're going to say it's going to be 1/2 12. Okay? 1/2 12 times, I'm going to give you this one. I'm going to give make that a given. We could go through the Pythagorean theorem and get that, but I'm going to give that to you in this one. So that's going to be 8. Okay? We're going to say this is going to be given, even though there's a way we can figure it out, let's just get to the formula here, use the formula, get our feet wet with that. Okay? So, the area of the base is going to equal 1/2, okay, 12, the base right here, small b, times your height, h. Okay, we're going to fill that in. The base is going to be 12 times 8, okay? And then that's just going to give us 1/2 of 96, which would end up being 48. Okay? Our perimeter of our base is just going to be 12 plus 10 plus 10. So we're going to get 12 plus 10 plus 10, or 32. Okay? So and this was in meters squared. This is going to be in meters, okay, or perimeter. Now, our height, when we're talking about the entire thing, is going to be the 8 right here, okay? So you almost have two heights. You have a height within the area here and a height within this being laid down flat, all right? So that's going to be also, it just happens to also be 8. Just ironic that that's also 8. That should be 32 meters, not equals meters. Okay? Okay, so we're going to look at what we have here. We're given we have our big B there at 48. So surface area is 2 times 48. That's our big B, plus our perimeter, which is 32, times our height, which is 8. Okay? And then we're going to end up putting everything together, and you're going to end up getting 96 plus 256. Okay? I always say 32 times 8 is 30 times 8, or 3 times 8, 24, with the 0, 240, plus your 16 gives you 256. And then we're going to end up with a surface area of 352 square meters. Okay, so that's our surface area of a triangular prism. Again, I may or may not have that on the worksheet, not sure, but we're just kind of exposing you to this. Okay, so that's basically what we're talking about with prisms. It's just a matter of understanding the formula and going by the formula. And like I always do, you know, I'll put some examples on the worksheet. Okay? Okay, the next thing we're going to look at is the surface area of a cylinder. Okay, we go to a cylinder, and obviously we want to identify what our radius is, which we all know. In this case, our radius is going to be from the center out. Okay, that's our radius. This is going to be our height right here. That's going to be our h, okay? And we're going to eventually find area of that circle, because that's going to be like our base, okay? So if we would find the surface area of a right cylinder, I'm going to raise this up a little bit. Okay, I kind of want to pass the picture, but I think we're all familiar with our radius. Okay, so the surface area is going to be 2 times pi times radius squared. And I'm going to put that, rewrite that over here. Surface area is going to equal 2 times pi times radius squared, which is really the area of the circle, plus 2 times pi times radius times height. Okay? Okay, so we're going to look at that formula. I'm going to raise this up a little bit. Okay, we want to find the surface area of the cylinder. Okay, so what we want to find is the area, if you were, you know, if you had a can or any type of cylinder find what the area is called. You know, if you wanted to wrap it with wrapping paper, the area of the wrapping paper you need to wrap. Okay, so what's given is our radius here, 3 feet. This is our radius. Okay. And this is our height right here. So we've got our radius and our height. We have to find the area of our cylinder here. Okay, we're going to have to find our area because that's basically what this is. Pi times radius squared is going to give us the area. I should say the cylinder, the area of the top of the cylinder, which is like the base. Okay, and that's going to be pi times radius squared. Okay, and we can even actually just put that right in the formula here. Okay, so we're going to do 2 times pi times radius squared, 3 squared, plus 2 times pi times 3 times our height, which is 4. So basically we're just putting everything into, this is our height, or our h. Okay, putting everything into the formula. And when you put this formula together, put it in a calculator, you're going to end up getting 2 times pi, and 2 times pi times 3 squared. You could, if you want to leave it in terms of pi, you would end up getting 2 times pi times 9, okay, plus 2 times 3 times 4 is 12 times pi, it gives you 24 pi, okay? So this is going to give you 18 pi, put this as 18 instead of rewriting another step, 18 pi, okay? So this is what happens when we put all this together. I was going to do it in 2 steps, but I'll just do it in 1. So you've got 18 pi plus 24 pi, that's going to give you an answer of 42 pi. And again, we've seen with this, we can come up with an exact answer when we multiply the 42 times the pi, okay? And when we get that, we're going to end up getting 131.95. So our surface area in terms of pi equals 42 pi, or 131.95. And again, that was in feet, square feet. Okay? Sometimes, again, you'll see your answer in terms of pi. Sometimes you'll see it in terms of an exact number, which all we did was we multiplied the 42 times the pi. Okay? Okay, so that's basically it for surface area of prisms and cylinders. And again, like I said, on the worksheet, 12.2 worksheet, I'll have a few more examples there with some notes on the side, and can't stress enough 2 things. Show your work to get credit, and make sure if you have any questions, email me. Okay? And good luck.